Board of Directors, Michael Jones, Deputy General Manager. Before I turn the presentation over to Sylvia and her team, I wanted to provide some context to the information that we're going to share this morning. First, staff with support from our consultant team has conducted a thorough and comprehensive analysis of all of the service disruptions that our customers have experienced since August of 2025. I want to definitively state that staff has not identified a single cause of the disruptions. Said differently, there is no smoking gun to share this morning. However, we have extensively evaluated all possible causes that could have contributed to these events. We focused on all aspects of our railroad, including our traction power system, our wayside equipment, as well as our rolling stock. I am confident that as we present our findings, it will be clear that we evaluated everything that we possibly could to get to root cause. We will also share the mitigation efforts, both completed and ongoing, that should provide confidence to the board and the public that we continue to operate a safe, reliable, and efficient transit system. Lastly, I want to address several misconceptions that staff has heard recently from the public and members of the BART board. First, there is speculation that BART leadership has intel on the single root cause of these incidents, but we are not sharing it. This is false. Second, there's a suggestion that blown insulators are the root cause of service disruptions. This is also false. I want to point out that blown insulators are a common occurrence on electrified railroads. It happens, and while it can cause arcing, it has not presented a dangerous condition to cause alarm. We have contacted several transit properties around the country, and we are not unique in experiencing blown insulators, and our maintenance and mitigation standards are in line with those agencies. We will discuss this in more detail during the presentation. Third, there is speculation that this effort did not require the assistance of external consultants and that the consultants don't have the expertise necessary to assist in resolving our challenges. I can assure you that the team we assembled exceeds the expertise of our in-house staff. They are credentialed professionals from global firms that have decades of experience in assistant transit agencies in tackling the issues that we are facing. With this context, I'll turn it over to Sylvia Lamb, AGM of Infrastructure Delivery. But before I do, I want to point out that we have our entire maintenance and infrastructure leadership team here in the room, and I'd like them to stand and be recognized. So these are the individuals that respond to the 1 a.m. calls, the 4 a.m. calls when we have these incidents, and they are responding with their frontline workforce and mitigating these issues. So these are the people behind the challenges that we're having, and I can guarantee you that they are totally committed to making sure that we move this forward in a positive direction. So with that, Ms. Lamb, I'll turn it over to you.
Thank you, Michael. I'd like to acknowledge also that Parsons was the lead firm in this effort for the root cause analysis, and Ebro Muftik, as well as Lori Colangelo with Parsons, is in the audience. And to my left is Zara Younisi. And Zara, while there were tons of experts involved in this investigation, working for Parsons, multiple subs, probably 50 individuals engaged. Zara is one of those experts. She's a California PE. She's also the chief engineer for 3VI, which is a subconsultant to Parsons. She's worked in the UK and the US. She's worked for London Underground. She's worked on BART systems before as far as traction power systems. She's also worked on issues for BART related to the track engineering, and so she's very familiar with our system. As she came in, she's also for other agencies worked at WMATA, again, London Underground, other places in the US, and she also has experience with CBTC. So her credentials are long and wide, and I'm only touching a small bit of it, but we're happy to have her here, and she's going to serve as the collaborant, the kind of focal point of all the expertise that was on the project. So to get started, I want to talk a little bit about the scope of this investigation. As you can see in the middle, we really focused on the area between West Oakland and Civic Center. So that's not to say that if an incident popped up that we didn't also include that into just to check and see if it was something holistic that was also added to this. We did do that, but from a root cause analysis perspective and a scoping perspective, it was really important for us to stay focused and not like kind of trace a thread down. And an example of that is there was an incident in Lake Merritt. That was incident number 3 during this period of time. We did go there and find that it was specifically a rod that had fallen from the ceiling and landed, which had caused that incident. So I just wanted to make sure that we had a understanding of what that scope was. And the time frame, we started, we looked at incidents in August, starting with August 29th. But if something pops up today, the team will go out there and look at that as well. It's not over. This is ongoing investigation, and we're continuing to look at any incidents that come up within our trackway. We followed a very scientific approach to this. That means that it had to be super methodical. And again, trying to get down to a root cause analysis is not an easy thing in a very complex system. It's a high voltage system. It's not unusual to see arcing or sparks on our system. So, you know, it was really important that we stay focused and keep a methodical approach to that. And that started with collecting data. That meant our data from, you know, that we have in-house as far as designs, as far as maintenance records, as far as other work that was going on, but also the very first thing that was done is for a whole slew of people to go to these incidents physically and look at them, and that's part of that collection of the data. So the process went through collecting the data and then analyzing the data and then getting down to some hypotheses. A fishbone diagram is simply a graphical representation that helps a team, after collecting a whole bunch of data, to kind of break down and trace through for root cause. It's looking for cause and effect. It's a common diagram that's used in lean practices, different quality practices. So this is a standard industry in order to do these types of investigations. And, you know, I'm not going to go through every single one of these, but it kind of gives you an idea of the extent of how the team went through to analyze root cause. You know, Michael said it, he kind of stole my thunder there about saying that this was a very thorough and comprehensive investigation and report, and again, ongoing. You can look at the amount of man hours that was put on, the amount of field visits. So site visits, we were in the tube, you know, 37 site visits, but that's not just to the tube. We did go to Lake Merritt, we went to other places, and that's not just the Parsons team. So the consultant team had, like I said, about 50 individuals engaged throughout this process, but we were all hands on deck. And those, you know, the folks that stood up in the back are not the only folks that are involved in this. There's actually more folks in there that didn't stand up. I was going to tell them to stand up, but that's okay. We have tons of people that have been involved. Those 37 site visits, probably, I would say at least 15 of them involved going out in the middle of the night. And sometimes that involved going out, working all day here, going through files of data, and then going out and leaving this office, taking a break for a couple hours, and then going to the site and going out into Graveyard with the power off to really investigate that. A huge part of this, too, going through the bottom right, is the amount of documentation that was reviewed and requested by Parsons and by the consultant team. And it's not unusual when you bring a consultant in, they're coming in cold. The first thing they want to know is all this information. Where is this? Where is this? Where is it? You know, and sometimes it can be frustrating. I'll make sure your mic's on. Sometimes it can be frustrating for the BART team because we want to get going, right? And there has to be a combination of that because the team needs to have all that information.
That's correct. The Parsons team did submit over 100 RFIs within three to 4 days, and we'd like to take a moment to thank BART M&E for the very fast turnaround on those RFI responses. Some were same day, if not same day, next day, so we do appreciate that.
Yeah, so there's a huge amount of data, and all the BART team was very supportive as far as, again, maintenance records, engineering records, everything that we could do. And the whole team knew that this was a top priority to get this investigation done and figure out what's happening in our system. So as far as when we get through the fishbone diagram, and I'll let Zara talk about the kind of hypotheses, but before she does, I want to just say, kind of again to Michael's point, that other than the Lake Merritt incident where we do know it was one rod that fell, every other incident has a combination of factors. It's not one single thing, and there's not one single thing that happened for all incidents, correct, Zara?
That is correct, yes. So this slide here represents the main group of hypotheses put together by the Parsons team. And in some cases, the incidents are straightforward, where there may be one or two causal factors. In a few of the incidents, they're actually more complicated, and it requires a detailed analysis to determine which one is actually the root cause. This represents a very comprehensive look at the system, as well as the subsystems and external factors, and also human factors. Thank you.
Thanks. So let me start with re-describing our traction power system. And you may remember when Miat was here a couple of months ago to give an overview of our whole traction power system. But I think it's really important before we get started today to talk about how our system works and kind of walk through that. Also, I want to point out is that at the end of this presentation, I think there's like 2.5 pages worth of glossary. It's really hard for us sometimes to figure out how to not use the terms that we're always using. So we wanted to include a glossary so that would help. So anyway, our power, as you know, comes from the utility. It comes in at 115 kVAC. The utility is we then step that down to 34.5 kVAC. And you hear that a lot, right? When we come and ask you for approval for a cable replacement, those are our redundant left and right cables throughout the system. That feeds into our substations. At the substation, it's more complicated than I'm going to describe it, but from a simple perspective, it's taking the AC, it's changing it to DC, and it's stepping it down to 1,000 volts. And that is used to power the third rail. So that is a connection from the substation to the third rail that gets the 1,000 volts out there. The rail cars have a collector shoe assembly, which means there's a paddle that rides along that third rail. And as it's riding along the third rail, it's pulling power to help it go forward and also to power the auxiliary systems within the train itself. When you're moving a train and the wheels are turning and there's different heat, there's also current being generated. That current is needs to go back to the substation. So if you follow the orange lines around, it's really important that we close the loop in any kind of electrical environment. So the paddle is pulling power from the third rail. It's moving the train forward. It's powering the inside, all the equipment inside of there. And then the wheels and the different heat are generating current. And that current goes back out through the wheels along the running rails to a negative return shunt. And that shunt has a cable that goes back to the substation. And again, that kind of closes the loop of our circuit with our trains. Also, in addition to that, we have regenerative braking. If you have electrical vehicles, you already know what regenerative braking is, but for us, I'm just going to describe it. Where the negative return current goes through the wheels back through the running rail, as a train brakes, that excess power, it goes back out through the paddle onto the third rail. And this allows any other trains within the vicinity to pull that power from that excess power as opposed to pulling it from the substation again, which makes us more efficient. This is exactly the same as it was in our legacy cars as it is in our cars today. So as we go through this, it really requires a lot of integration as far as this discussion. We can't just look at one thing in a bubble and say that's it or that's not it. We have to look at how all these things integrate together. And you probably remember from the CVTC presentation how important that systems integration is. So as Zara goes through the rest of these slides, she's going to talk about not just these individual pieces, but also how do they relate to each other. And so with that, I'm going to turn it over to Zara to talk about the very first piece.
Thank you very much. So we'll start with traction power and looking at some of the findings and the analysis. What we're looking at on this slide is a rough representation of the traction power substation configuration in the vicinity of the Transbay Tube. The green icons represent the traction power substations that are in service. Originally, and so we're going to start with looking at the design intent. In the original design, there are two traction power substations. On the west side in San Francisco, there is MTW, and it is capable of providing 10 megawatts. And on the East Bay, it's matched by KTE, which is shown in gray. That's the gray icon, because it's undergoing a planned upgrade. To facilitate that upgrade, BART introduced a portable substation known as KPS. We looked extensively at the dynamics of this and the records, and it was determined that this portable substation has been used elsewhere successfully on the system. It is interesting that it has a 5 megawatt rectifier, and it's supplied by a 3.2 MVA transformer. And so therefore the overall capacity is noted on the diagram to be 3 megawatts. Typically on the BART traction power substation, they are 5 megawatts, typically give or take, and they're maybe 1 to 2 miles apart. So what was interesting here is while we originally had a 10 megawatt to the west and a 10 megawatt to the east, that has dropped down to a 3 megawatt. So this is the only place on the system where there is a delta of 7 megawatts. This is being analyzed in terms of what's happening with the power flow. Does it lead to an unbalance? Is there a circulating current, for instance? These are some of the hypotheses that have been bounced around. And in addition to that, to be able to evaluate that further, that is happening through modeling. I would like to also point out that through our review of the records, this change happened in 2021. So it has been operating in this way for about 4 to 5 years, and therefore it's not considered to be the root cause. However, we're looking at whether any of these small changes have moved the needle in terms of the power quality.
Yeah, and Zara said it, but I just want to repeat, that KTE, that gray substation, it is out of service because we had planned for a couple of years before that to upgrade that substation. So it was a planned out of service, and we were waiting for, well, not waiting, but when the portable substation was also available, it was all planned to be done this way.
Thank you. So another finding and design change that we came across through our review. Now, this occurred through site inspections, and I'd like to take a moment to thank the BART structures crew and BART maintenance for supporting these requests. They were through the night, back to back. I personally did go out and walk the track as well to perform these inspections. And through these inspections, we were able to verify that during the dates of the incidents between August and October, the crossbonds were not in place. Now, there should have been 10 crossbonds in place between the Transbay tubes. So what we're looking at on the slide is the purple line represents the crossbond. It's essentially a cable that connects between two tracks. It helps provide additional paths for the return current to flow back to the substation through both tracks. And when, upon our further request for information, we determined that they were removed to support a single tracking project in 2020. And one finding is that upon completion of that project, the crossbonds were not reinstalled. However, they have since been reinstalled.
Thank you.
Oh, I should add also that because this happened in 2020 and it ran in that configuration for about 4 to 5 years, again, this is not considered to be the root cause, but taken together with the previous finding and then this as well, we're looking at the cumulative impact. So this is being analyzed through load flow modeling.
Yeah, and we did, since you added more, we did talk through why would those crossbonds have been removed during the 2020 project. And you may have remembered from the beginning when I said negative return is going back through those running rails. So those crossbonds connect all the rails together. So there was a concern from the team working on that one set of tracks while we were single tracking on the other set of tracks that there may be a potential for, feeling that current. There are other ways to make sure that doesn't happen, and so this was, I think, put in place as kind of an extra measure just to make sure that those two tracks were isolated.
In order to take a closer look at what might be happening on the power system, the Parsons team did recommend installing the power quality monitors. On the top left, you'll see a photo of an actual PQA from this investigation, PQA being Power Quality Analyzer. These are also known as data loggers. The load monitoring tests were performed to look at the incoming power quality, so looking closely at the incoming currents and the incoming voltage into that substation, as well as recording any harmonics. If you're not familiar with the term harmonics, you can think of them as unwanted frequencies. Now, harmonics are not really of interest to us on the DC side, however, they are on the AC side, but they could result in unwanted frequencies on the DC side and a change in the DC ripple. So I should also explain what we mean by DC ripple. So on a typical substation that has a 1,000-volt DC output, much like a DC battery, you'd expect that to be a constant voltage. But in practice, it does come with a small amount of ripple. That ripple is normal. These are 12-pulse rectifiers. And through the process to take AC and rectify it, it's never possible to completely eliminate that ripple. So on a 12-pulse, it's a 720 hertz ripple. And what we were looking at is, did that increase with all of the minor changes here and there? Did that DC ripple look different? And there are additional loggers. Bart took some proactive measures before the Parsons team started to install DC loggers. So similar to the AC loggers that were installed through this investigation, there were DC loggers looking at the output of the substations. The power quality analyzers that were installed were to look at the AC side coming in. So that gives our team a complete picture, and that data is currently being analyzed. In fact, those power quality analyzers are still in place at the MTW substation. They were installed on the East Bay side at KPS and on the West Bay side at MTW. And what was very interesting is that MTW, the incoming voltage, was higher than expected. And if you can squint enough, you might be able to see that on the A phase, it was 815 volts, and then 810 on the B and the C phase. So this is not the 34.5 coming in, because the loggers were installed on the secondary side of the transformer, in between the transformer and the rectifier. So that line-to-line voltage should be 783. So that's how we know it's higher. And when we account for the turns ratio, we calculate that back, and we were able to determine that basically what that means is, instead of 34.5 coming in, it's closer to 35.5 kV on the B and C phase and 36 kV on the A phase. So overall, though, this is really a change of about less than 5%, which is considered to be a tolerable limit. What we are currently looking at is, what were the harmonics associated with that, and did they result in any unwanted frequencies on that DC side that perhaps the vehicles cannot tolerate. The vehicles are equipped with line filters, so they are designed to handle these types of variations, but the analysis requires a further look in terms of modeling and calculation to actually quantify that value. There are also standards that govern this. The EN standards and the IEC standards look particularly at electromagnetic compatibility and immunity limits for these systems, and that is also part of the analysis that's being performed by this team.
Yeah, and so just to kind of recap, one of the things that Zara said is some fluctuation is expected, and in most cases, I think you've said within 5% is tolerable. As long as, I think if it's not sustained, right? Like a sustained ripple could be more problematic, but also something that we have for next steps and opportunities for improvements. Right now, in order to do this, Maintenance has to go out and put a logger there physically. So it's kind of a snapshot in time while that logger's there. So outside of that time, we're not sure when that's going up or down. And so looking for remote monitoring tools that would allow us to do this logging in real time moving forward is one of our recommendations.
Thank you. And with the hypothesis that the small incremental changes may have led to an increase in that DC ripple, the BART data loggers were looked at, and the output did seem to be consistent with DC ripple outside of the normal limits, but that does not mean that they are outside of the tolerable limits, and that's why the calculations are necessary. So in addition to that, now we'll talk more about the negative return and the grounding and bonding. So again, thanks to the BART Structures team and BART M&E, the inspections were facilitated through the Transbay Tube to field verify all of the negative return cables. And we talked briefly about the cross bonds, so I won't repeat that. But there were also some electrical tests performed, and what we can see there in the lower left corner is a fluke meter, just looking at the resistance in particular, this time between the running rail and the track slab. And in two places along the tunnel, that resistance was low. We don't expect it to be low. We want the running rail to be insulated from the track slab. There were further tests performed, in particular looking at the negative grounding devices. So if anyone's not familiar with the negative grounding device, the running rails on BART can have the rail potential can increase to a slightly higher voltage, and once it reaches a specific set point, those NGDs will fire and ground that running rail. It is a safety device. So the NGD at Powell was found to be shorted. That was taken care of by the BART team. And after that, we did see an overall improvement in those resistance values. So moving on to the third rail insulators, these were looked at extensively, including wayside inspections and off-site inspections. A number of insulators were taken to an off-site lab. They are pictured in the bottom right in various conditions, several as found and 2 new. The tests that were performed in 2 different labs actually included destructive testing and non-destructive testing. Some of the observations in the lab, including the forensic testing that was performed, the surface layer of dirt on some of those insulators was found to be conductive, at least on the ones that were tested in the lab, and the shims, which are the thin layers of material that sit beneath the insulators, they help adjust the height of the insulators. They were found to be damp. But overall, the insulator condition is consistent with normal aging and the environmental exposure expected within the tunnel installation. These findings are still not considered to be the root cause, because with looking at the specific incidents and all of the factors, there appear to be other factors that may have initiated some of these insulator failures. And it's also worth noting that not all of the incidents included insulator failures. So another finding, which we'll touch on later, is rail relay storage practices.
So, if you don't mind, let me just jump in one real quickly on the insulators, just to follow up from the earlier conversation. So there's also been news reports that we are cleaning the insulators, and that's partially true. We have cleaned all of our insulators from Embarcadero to 24th and Mission. We did that primarily because we've had incidents in this area, which we're focusing on the root cause now. But it takes a crew of 8 overnight to do 20 insulators. We have over 100,000 insulators, and there's varying degrees of insulator maintenance across the industry. So I want to put out there and clarify that we are not planning to clean all 100,000+ of insulators, but we have taken care of this area just to make sure that we have done everything that we possibly can to mitigate the challenges that we were having on the M line. So, sorry, Zara.
No, thank you. Right, well, let's maybe go back one slide just to point out that the team has got extensive experience in analysing insulator failures and being able to determine whether that insulator was the initiating cause. So we will provide an example of that on the next slide. So this is from one of the incidents, and this is how we're able to, for example, determine if the insulator was the root cause or not. So what we're looking at on the red and black line represents the cover board, and the thicker grey block beneath it represents the third rail. So it's as if you're standing in front and facing this third rail. The white rectangles with the blue underneath represent undamaged insulators, and the red represent damaged insulators. In this case, we'll start with the yellow oval. There was damage noted to the top of the cover board that would be consistent with that damage occurring from the top down, from an initiating source. And we also can see here, when insulator fails, there is a characteristic soot deposition pattern behind that insulator, usually aligned with it. Not always, but in this case, we did see it at the location A, and we did see it at location C. Now, we do also have a team of fire life safety experts on this panel that have been involved in this review. And what's interesting too is that at C, it does tail left in the direction of travel. But the most interesting finding is that pattern did not exist behind insulator B. It was nowhere to be found. The wall was relatively clean, the tunnel wall. But what was interesting is it was projected downwards onto the track slab and in the direction of travel. So the hypothesis that's under evaluation right now is that insulator B did not fail on its own. It was an initiating event from above, a DC arcing event. And we'll look at some of the actual photos from this incident. So once A, then B would have failed in quick succession, as well as C. We're still evaluating A. So this is under analysis to determine if that initiating source was at play as well at the location of insulator A. So on the top right is a photo of the cover board that I mentioned, and there is a stepped profile on the top of that cover board where it's evident, based on this evidence, that the damage was from the top down. And it also aligns with the area of the material loss in the third rail. So for third rail to have essentially a hole in it of that size, that is typically due to high energy arcing. That would be the type of energy required to essentially vaporize that metal in that location, and that's that beneath it is the remnants of the insulator, and you can see that soot deposition pattern on the track slab. And also to the left is how it looks on C, where it's directly behind where the insulator stood.
I wanted to add here, just to, again, give kind of a level of the effort that was put. Not only, was this kind of detail looked at, but even that, when you see that splatter behind it on the wall, scrapings were taken of that and sent to a forensic lab to determine what materials that was as part of the investigation, just to give you a little bit more context on how detailed and how thorough the investigation has been.
So in addition, just to be very thorough, the team also looked at the protection scheme. And the third rail is protected by DC breakers, much like the breakers you'd find in your home panel, except these are DC and much larger. And they can act very quickly to trip and isolate faults. The review of the records revealed that, in fact, so typically the DC breakers all have an ability to trip without an MPR. The MPR is a multi-function relay device that helps customize some settings. We can think of it as an additional layer of protection. When, based on the review of the records, these functions have been disabled. during the time of the incidents. Now, that does not mean that the breakers did not have the ability to trip, because they do have a trip mechanism, but it is more basic, and it would have relied on that basic mechanism. So further RFIs were submitted, and we asked why they were disabled. And the reason that was provided is that they were nuisance tripping in the morning upon return to service. Perhaps Sylvia might want to weigh in.
Yeah, well, there was apparently nuisance tripping, which impacted being able to run cars in the morning, like consistently every morning. And so we found that they disabled these in order to make sure that trains were running smoothly. I also want to add, though, this one has been replaced, and you see the old one versus the new one, although to me they don't look a whole lot different. But our MPRs in our system have been aging, and a lot of them are within 20, 25 years old. We do have a project, and we have had an ongoing project to replace MPRs. So we're about 60% done with that. It's a $22 million funded project. It should be completed within the next 18 months to 24 months. But this area had not been done at this time.
So moving on to vehicles, and this team does include vehicle specialists and SMEs from actually all over the world. And what we're looking at, we'll start with the collector shoe assembly. On the top left, there is an image of a typical collector shoe assembly, and the bottom left shows its position on the vehicle. And then in the bottom right, it's a close-up view of the collector shoe and the braid and the fuse. So we will talk more about this on the next slide, but I just wanted to give you an overview of where it's actually located. So, okay, four of those collector assemblies from the instance were taken to an off-site lab for forensic testing.
Next slide. There you go.
In addition to that, 4 fuses were provided to the Parsons team by the BART vehicles team. These fuses appeared to exhibit a non-standard failure, and they were taken to a lab for further testing, including forensic testing. So fuses, much like the fuses that you find in your home appliances, have a fusible link that will melt if the current exceeds that threshold. And these fuses are different because they're slightly larger, but they also do include that fusible link. But they also have quenching sand that helps extinguish that arc at that point. So when that fuse typically fails, that we'd expect that sand to turn black. But in this case, the sand remained white. And we can see extensive damage to the exterior of the fuse body, also known as carbonization. The tests were extensive, including an elemental analyzer test on the area that looks like brass. It was confirmed to be brass. So those pins are actually zinc or zinc plated. And it was interesting that brass was found there. That is, for brass to form with zinc, we need copper and an extremely high temperature. So it's yet to be confirmed, but the hypothesis is that there was high energy arcing in that area. In addition to that, there are other signs looking at the lug. So if you're not familiar with the lug on the top right, we pointed to the braid on the previous slide. The braid is connected to the fuse, and that rectangular piece that's coming in on an angle.
With the 2 holes.
With the 2 holes, thank you.
Sure.
That also has material loss. You can see that there's a kink in it. It's not designed that way, so that is another sign that there was perhaps high energy arcing at that point. And more evidence of that was looking closely at the inside of the end cap where there is beading. And that's basically those tiny little metal balls that you can see there that would be indicative of perhaps a high energy, maybe a thermal event or arcing within the end cap, and it may have come from the lug itself. However, this is still under analysis. Further testing is recommended on the fuses, and we will have additional updates on that in the report.
Yeah, and so on the quenching sand in this kind of event, Zara, you're expecting to see that sand be black, right, instead of
Correct.
the white, right? Okay, next slide, Bob. I'll start with the rail storage. Zara brought it up a minute ago briefly, but at BART, the maintenance practice for years and years, I don't even know, like forever, has been to do our rail in 800-foot sections. And I noticed before, or when talking to one of the directors about rail relay, so let me just explain. The term rail relay just means replacing the rail. That's our projects that we do all over the place. But given the short windows of maintenance windows during the blanket, that 3 hours where the power is off, it takes a long time to get that rail moved out to the right section and then to do the work. So what the practice has been is to bring rail out and place it wayside either in between the third rail and the running rail, or in between the two running rails. And then at a later time, when we're doing the actual project where BART maintenance will go out when we have single tracking or weekend shutdown, and then replace the rail. They leave the old rail there, and then over the next period of time, come out during the blankets and pick that rail up, or break it in. They cut it into sections and then take it out. But so what the team saw, and now I'll turn over to Zara.
Thank you, Sylvia. So as part of the analysis on track, one of the findings was a non-standard practice to store ribbon rail in the gap between the running rail and the third rail. And in fact, to accommodate that, it does appear that the cantilever brackets were cut back. So in that top right photo, you can see an example of that where there is really like a diagonal, where you see that diagonal cut. That was cut back to accommodate this. So why is this important? Well, there was one event that did appear to include the ribbon rail, or involved the ribbon rail. There was evidence of arcing found on that ribbon rail itself. So, yeah.
And since the investigation, all that rail's been removed in this area, by the way. So, and then you want to talk about the insulated joints.
Insulated joints were also carefully looked at. So, insulated joints are a normal part of the BART infrastructure. They're typically used to help with the detection of trains. And negative return current has got to go around those IJ locations. That's typically facilitated by little jumpers that go around the IJ. These are insulated joints of current. The DC return current cannot pass through them without going around. What we had noticed is that in support of the earlier project that was mentioned, IJs were installed at the locations shown on that graphic. So to picture an IJ, there's a photo of that captioned, and the graphic is showing the green rectangles as the IJs that were installed to support those projects, and the purple was also green at one time. So during the investigation, it was determined that through the rail relay work that was done on the M2 track, so basically a new length of running rail was installed on the M2 track on 1012, and that IJ was removed. And then 2 weeks later, the other side, that running rail on the other side was removed, was installed, and then that IJ was removed. So basically, for a period of 2 weeks, there was a different operating condition in play for at least two of the incidents. So that too is being analysed, and again, it requires modelling to fully determine what the impacts are of this.
Thanks. Next slide.
Finally, just to be thorough, there was a huge effort to look at environmental factors and human and external factors. So, I mean, the slides I think are self-explanatory, but there is evidence of water intrusion in places. During one of the inspections, our team also noticed there was standing water in the Transbay tube, but only a small area, and we submitted an RFI, and that was confirmed to be due to a sump pump, broken sump pump that's since been repaired. Generally, there's debris, as you can see, throughout the platform areas and the tunnel, and rail grinding as well, which I believe Shane can speak more to that on the rail grinding practices, because there are there are good measures in place to minimize that. So overall, because these incidents did happen in the TBT, the environmental factors will probably remain as one of the contributing factors, but not necessarily the root cause.
Next slide.
So the final area is the interface, and the interface is basically where all disciplines come together, and this is where we have basically the interaction of the shoe and the third rail. The team has looked at extensive data, including the geocar data, looking at track defects in particular and their locations. The team also performed a third rail gapping study, which confirms the location of third rail gaps. And one of the hypotheses is the possibility of a shoe bounce or a quality of contact issue where a DC arc might momentarily form, but if it does form, perhaps it's being sustained, and we're looking into this as a possibility. But while we are looking at this, it is also important to remember that a small amount of arcing is also normal and on major, DC electrified third rail transit systems. It's momentary, it's not expected to be a sustained arc. But once a DC arc does form, it is very difficult to break that arc.
Next slide. These are all the improvements that have been implemented while the root cause analysis team has been working on the investigation. So I just want to mention that the first one up there is that there was a, not our structure, but San Francisco, at the San Francisco transition structure, there were 2 transformers that had been out of service, one from I think December of 2024, and then one in February, and that's been since put back in place. But all the ones with check marks are the work that maintenance has been doing to, for instance, restore the cross bonds, clean up debris, do, as Michael mentioned, cleaning the insulators, and also looking at the repairs of the negative return device. That one short was repaired, but we're looking at all the other devices as well, and looking at which ones need to be prioritized to be repaired or replaced. There is already a project for that, for maintenance to do that replacement. RSNS is working on further testing and looking at different things with vehicles. So there has been a lot that's gone on. Like I said, maintenance has removed that ribbon rail, and also been replacing direct fixation pads, which were found to also be degraded and also had some moisture. And again, that's a project that's being done by maintenance. Next slide. Do you want to talk about these? So in each, I'll talk about that. So we said in the beginning that for each incident, it was most likely multiple things that had caused those incidents. And there wasn't, even though we're kind of combining these into categories, there wasn't like one thing that affected every single incident. So this is just kind of a breakdown of the incidents that happened and what were the potential causes related to that. Again, except for incident 3, where we know that there was a rod that fell from the ceiling that had that impact. Next slide. And next steps, before I get started, I just want to say the picture on the right is not the BART system. It's a, it's a picture from the rail inspection vehicle software to use for display purposes. But the next steps, there's a couple of big ones. So first is finish the modeling that the consultant is doing of this area. They are putting in every single piece of equipment, everything in the system, just everything having to do with that. There's a couple things that are good with that. One, it's going to help us run different scenarios to validate the causes that we think about, that we've come up with, or the team has come up with, and then also be able to run scenarios to see if we can recreate that explosion digital or arcing digitally as opposed to physically. We're also looking at opportunities to better maintain our insulators, whether that means looking at different designs and materials that are being used nationally. We've already been in touch with many other agencies on their cleaning practices, as well as the type of insulators that they use. And then Zara mentioned for the vehicles, we're conducting some additional vibration studies and tests on the collector shoes. And then for policies and procedures, working with safety, I think between safety and maintenance to develop a configuration control type document and procedures so that when certain changes are made in the system, they are signed off. Like that everybody knows that that's happened and they all agree to why it happened. And in that document or in that procedure, also what is the date for that to be put back the way that it should be. So I think that's something that's definitely an opportunity for us. And then I mentioned earlier about having constant, continual remote monitoring and logging tools. I want to note, and one of the reasons that we added the picture to the right, you guys, most people are familiar with our rail inspection vehicle. We use that for mostly, we've been using it mostly for track, looking at track defects and needs there. Just this week, we've started running it with power on to use that vehicle to look for any kind of heat anomalies or any kind of power anomalies in those areas. So that's, I think they've done 2 runs this week. So that's also something that we'll evaluate, you know, the data that we're getting from there and how helpful that will be in the future. And with the modeling, you know, depending on how it turns out and what we're able to do, it may be something that we want to expand to other pieces and the other places in the system, again, to help identify and be proactive about any potential vulnerabilities. And with that, next slide, we will take questions.
Thank you, Michael, Sylvia, and Zara. I appreciate the very in-depth presentation about these incidents. Let us first turn to public comment before we go to director's comments. So, District Secretary, what do you have for us?
Okay, we have 4 public comments at the moment. The first is Glenn Overton. Glenn, please come up.
Madam President, Mr. General Manager and staff, Board of Directors. California in 2024 was a $4.1 trillion economy. What part of that economy does BART generate? You have objective or subjective accounting. I don't care whether it's objective or subjective. The state needs to realize its responsibility to refurbish a more than 50-year-old system. Those parts need changing. We take care of our bodies. We take care of our homes. We stitch our clothes, mend our socks. We don't take care of insulators because of budget neglect or something of that sort. A $4.1 trillion in 2024 budget, and all we're asking for is a budget that will renew this system.
Thank you, Glenn.
Jerry Grace, followed by Barty Spitz, Alita Dupree, and Roland. Jerry?
Good morning. I hope this is still morning. It's good afternoon. I don't know which. But I'm up here because will you please put the picture number 13, please? I thought they would show the picture. I'm trying to point out to you guys about the picture up there on that screen because that machine that you use for the clipper and that the machine I'm talking about the last time and how for me use that machine because I do not know how to use that kind of machine. I had a BART station machine. I got that one, an AC Transit, had the same one before. They changed it. You have a San Francisco movie one. I don't like that one too much. And the same thing I just saw now, the yellow one. I don't know how to use that one, and the San Francisco movie one. But everybody else have the same one, the gray one, better, the yellow one or the San Francisco movie one. I don't like that one too much because I do not know how to use that machine. I tried to use it once before. I don't know how to do it. What I'm trying to, I hope you understand what I mean. Please, I wish somebody or someone or somebody could show me how to use that kind of machine. I asked somebody once before on San Francisco, and nobody there at all cannot help me. I didn't see nobody there at all help me using the machine, add more money on that clipper. Thank you.
Barty Spitz, please go ahead.
Actually, Bob, I think GM Powers was going to respond.
I'll make it my business to help Mr. Grace with learning how to use that machine. Chairperson Foley.
Appreciate it. Thank you.
Okay, Barty.
Thank you. My name is Barney Smith. I'm a licensed professional engineer with over 25 years experience as a BART engineer and a fire life safety expert. Looking at the report, I'm not sure what the hired expert consultants provided BART. There is no definitive conclusion. The report does not clearly present a root cause for these traction power arcing, flashover, and fire incidents. Of the 9 incidents investigated in the report, 1 within Lake Merritt Station appears to be a human or trash incident, and another has no comment. That leaves 7 incidents, 2 of which were in the Transbay Tube. What is the root cause? It is clear from the report that 5 of the 7 remaining incidents have 4 or more possible causes, and that 6 of the 7 incidents have traction power transients as a cause, and all 7 incidents have environmental factors as a cause. Environmental factors are defined as metal dust, rail dust on the insulators, and moisture in the air. While some tunnels are very wet, like the poorly constructed tunnel from Colma to the airport, they are not relevant. The Transbay Tube is very dry. So approximately 5 of the 7 incidents are in dry areas, leaving metal rail dust as the most likely root cause. Since insulator cleaning stopped 5 years ago, but was restored in December, note that 8 incidents took place in the 3 months between late August and late November. And only 1 incident, under investigation, has happened since the cleaning of the insulators restarted in December. The missing crossbonds are likely a contributing factor, as electrical power will choose the shortest distance to complete the circuit. The missing crossbonds force the power to arc down the dust-coated insulators. Note the significant coverboard damage. This indicates fire and is the source of the smoke that hindered train operations in the Transbay Tube on August 29th. Hope this is helpful. Thank you.
Thank you, Barney.
The next speaker is Alita Dupree. Alita?
Thank you, Chair Mark Foley and members. Alita Dupree, for the record, she and her with Team Folds representing Skirt Folds. Thank you for the report. I think it's comprehensive and helpful. I like going to the source. You know, these incidents are like snowflakes. None is really like the other. They may have common themes, but they still have differences, even if they're nuanced. Arcing in the system does happen. I go to New York and I see arcing in the subway all the time. I was riding a Metro North train from New Haven, Connecticut, and I was riding through the big rail yards that lead into Grand Central Terminal, which is located in New York City. And we were in a yard, maybe, I don't know, 20 tracks wide, and there was a big bang and flash that lit up the whole tunnel, and I think it kicked up a little bit of dust. That's arcing for you. And we proceeded as normal. And I'm sure they have ways that they saw what happened and they addressed it. And I appreciate the explanations about AC and DC and Ripple. I know it's not the same thing as the wine or the alcohol known as Ripple. And, you know, AC is like a skirt with folds, and DC is like a skirt that does not have folds. And Ripple is kind of like having folds because no skirt is totally smooth. So you're always going to have some wrinkles in there. This is what I'm seeing. Now, how do we make sure these things don't happen again? And I do know that Bob Powers and Michael Jones, your management team, does take safety very seriously to the point of being paramount. I ask that you take it seriously too and remember that BART is the people's system. Thank you.
Thank you, Alida.
Sorry. And our last speaker is Roland. Roland, please go ahead.
Thank you. Good morning. Happy New Year. Well, I just want to express my personal gratitude for the quality of this report. And I'm going to circle back 11 years to show you how BART have moved forward in terms of transparency. I'm talking about the incidents when we were getting voltage surges. We now know the voltage, which is not 750, 783. And we were surging to 1500 volts. What was happening is that people were going at night, reprofiling the rail, but they were not picking up the shavings. And what ended up happening is that we had two sections feeding the same section of third rail at the same time, and that's how we ended with 1500 volts. And I'm not going to get into the details how we eventually figured it out, but what I can tell you is that what I'm telling you is probably the first time you ever heard of it. There was a complete blackout. There was no explanation. And suddenly the problem disappeared and, you know, people just went on with their business. Fast forward 10 plus years and look at today, the transparency, the amount of analysis. And that is a direct result of good governance. Thank you, BART. We're in good hands. Thank you.
Thank you, Roland.
That was the last public speaker.
All right. I will now turn to director comments, and I do not see any directors in the queue at this point. Director Rayburn.
Oh, I'm first. I really don't feel qualified to speak elaborately on this. My academic training was not in the operation of high voltage electrical systems as at BART. Hence, I've refused to speculate on the 9 incidents. They involve power that disrupted service between August 29th and December 5th. Instead, I've encouraged our general manager to seek explanations from professionals and implement the necessary changes to end further delays. That's all of our goals, I'm sure. I am satisfied that the root cause analysis report we are reviewing followed a rigorous investigation and scientific process. Is the report conclusive? No, but it identified several contributing factors. BART has already acted to change operational procedures and advance numerous infrastructure changes, as illustrated on page 23 of the report. This allows me a degree of optimism that we're doing our best to protect our passengers from harm or delay. As well, in the near term, I anticipate completing the upgrades to the 10 megawatt Transbay East substation, the KTE abbreviation, to replace a temporary 3 megawatt portable substation. I also anticipate the operation of BART's modern rail geometry car to inspect the system while the system is energized. And with those additional data points and removing variations in some of the potential causes by correcting the cross bonds, I think that's a critical aspect of what we've done already. So all I can say is good work so far, and let's keep working at it until we get it down to no defects. Thank you.
Thank you. Any other director comments? No. We have a virtual system you can use. Director Ames?
Sorry, I have a little technical problem with my computer. Okay, sorry, I would like to go to slide 3. Oh, I can't look at the slide, so I need some technical support, but can we go to slide 3, please? Yes, okay. So on August 29th, we had a evaluation, staff did an evaluation on the smoke in the tube. And it was on August 29th. And we also had 2 other incidents that I don't see on there. And there were 3 separate incidents. They were not collectively the problem. It was very specific, different locations. So we had a power outage at West Oakland in the morning. It was like around 5 a.m. So that was likely due to a malfunction with the switches, which maybe even could equate to something that happened in San Leandro, but not as bad. But we lost power completely in West Oakland. Then in the afternoon, there was a train that lost a paddle, a car lost a paddle, and a fuse was blown, and there was a small fire. And that was in the afternoon. I think it was around 2 o'clock somewhere. And then we had the smoke in the tunnel, which was a commute hour, around 5 o'clock. So this is why I don't think collectively all of these things are forming to an unknown situation where we have hypotheses and we have more questions. I think we have isolated events that we need to hone in on. And I just want to now focus. So right now, I don't see those incidents on August 29th. Right now, it looks like we're just focusing on loud noises, insulator flashes. But I really want to hone in on August 29th and get more information on this, because I do think we can get to the bottom of the root cause quickly. Although we have a lot of good analysis that shows there's room for improvement. But I want to go to slide, I guess, 4. So this to me is a slide that's telling, because you need to define the problem before you collect the data. So did we define the problem here? It doesn't look like we did. We went to this really giant field of possibilities and created hypotheses. So this is a frustrating report, although there's a lot of good data in there to look at, but I don't see massive, studies and more follow-up in the fashion that's being presented today. But so again, I'll go back to August 29th. I would say, what data did we collect, for example, on the power outage at West Oakland? I'd like to know what that is. And then why are we having paddles being removed off the train car? And then we've got the insulator problems, which is likely the cause of the Transbay Tube smoke event. Because I do recall when we got an evaluation from staff on September 11th, there was a blown insulator picture. That was the 29th. And we showed the blown insulator, and it looked conclusive it was an insulator. So when we started compiling data, I guess I'd ask the consultant, when you did all these RFIs and you got information, did you get information on the maintenance of the insulators?
Yes.
So what was the determination of the maintenance on the insulators? I apologize for my voice.
Well, we reviewed all of the Maximo records, and it does appear that there is a maintenance process in place for the insulators. We did also obtain that data on the West Oakland outage that you're referring to. We've looked extensively as well at SCADA logs, ICS logs, and as well as the field investigation and forensics. But overall, the information is as presented here. There is nothing, there's no evidence currently that would suggest that the insulator was the root cause of that particular incident at this stage.
So I just want to drill down on this because I want to understand what was the maintenance for the insulators when this data collection started. I just want to know what was given to the consultant and the data of what we did on the insulators. What was the maintenance program? So maybe we got to get back to me on this.
Well, I think there's some confusion. So I will speak up and then we'll go from here. There is some Maximo data that the consultants looked for. There's also replacement projects that say if there's a if there's a defect or we see a defect when we're inspecting it, that we should replace the insulator. But I think what you're maybe getting to the question is did we have a cleaning protocol in place? And I think the answer is no, we did not have a cleaning protocol in place.
So can we get the information of what we were doing and
Sure.
why we stopped the cleaning? Because I think this is a repetitive, a question I get often from the
Yes.
press.
Yes, understood.
So I would like to get that, and I appreciate you trying to be transparent on this.
Sorry, Director Ames, the last cleaning program we had, my understanding was we were using dry ice and it was deteriorating the quality of the insulators, and that's why we refrained from doing that moving forward.
It would be great to get the detail as part of this investigation, what was happening and then why it stopped, just on the cleaning itself of the insulators. So let's, this is the scientific approach. I think, did you on the data collection, I guess maybe we can jump over to another slide because this is not very exciting. We can go to the paddle, showing a paddle of the train. Oh, there it is. Well, the collector paddle. Oh, you want to do another slide? Yeah. Oh, yeah. So I'd like to know why that paddle got dislodged off the car and how many times that has happened during this time frame. So to me, this is another data point that's interesting, like what happened, and I know you're going to evaluate this. I guess it's called a collector shoe. Sorry, it's not called a paddle. Sorry. But to find out why these paddles are coming off the cars is a concern. This is a separate issue now. We've got insulators, and now we've got this issue. This is a car issue, train car issue. And if a paddle comes off and doesn't connect to the third rail, what happens to the system? Does it a fire start? Does the fuse blow? Because that was my understanding.
Director Ames, I'm going to ask Leo Pica, our Chief Rolling Stock Officer, to answer that question. I will say that I think Zara and Leo will say that that is a common occurrence as well, but I'll let Leo speak for himself.
Thank you.
Hello, directors. Leo Pica, Chief Mechanical Officer at RSNS. So the paddles are designed to break. They have a notch in there, so they're designed to break. So when a paddle breaks, the ore collector on the car will carry the load, and even if two paddles breaks, the rest of the cars will take over. So they're designed to break. It is better for the paddle to break that, than damage the collector assembly. That assembly that is on red with the fuse and other items. So.
Is it your understanding that if a paddle breaks, something, the fuse in the train car could blow, from your experience?
So the paddle is what connects to the third rail. So once the paddle is broken, no power is going to the fuse or the collector assembly. Then the ore assembly on the ore side of the car will take over. Also, when the trains travel, right, each car has 4 paddles. So as the train is traveling, any one of those paddles will collect power from the third rail.
So my understanding is there's a surge of power without the paddle, and then the fuse blows. Is that not correct? Maybe I can ask a consultant this. I'd like to know the nexus between the blown fuse in the train car and the paddle issue. So maybe this can be done further. I just thought we might have known.
Director Ames, we're happy to bring you into the office and walk you through and trace the power from the shoe collector to the paddle. Happy to bring you into the office with Leo and walk you through very patiently all of those mechanics.
Okay, I think it would be good to know, because I know there was a fire that happened when that paddle came off, a fuse was blown, and it was a very small fire. It wasn't huge, but it got resolved. This is all on August 29th. So I think that's a separate issue, and I'm glad you're looking at this to find out what's happening between, I guess there's another picture of the fuse, but we've got fuses in the train cars that are also a problem. So I'd like to know the nexus of what's happening between those two systems, and that's a train car issue. And I think I just wanted to maybe conclude to the, because I know there are a lot of questions probably, maybe to the next steps. Wait, I want to go right before the next steps. And I just want to point out something to the consultant, because I know you've worked with WMATA. WMATA, Washington Metropolitan Area Transit Authority. This is in Washington, D.C. Just people don't know what WMATA is. The Federal Transportation Administration actually gave a safety directive to WMATA. And I just want to read this because it's related to insulators. Excuse me, let me just look here. Where is it? Apologize. Okay, WMATA, this is from the FTA, it's a safety directive. WMATA must update design specifications for third rail insulators and establish update procedures for testing, storage, install, inspect, cleaning, and replacement. And it goes into details related to that directive. And then the other directive is WMATA must explain the original intent of replacement program, define the rationale for stopping the program, and clarify intentions to reinstate the program of putting in, I guess what they did is they stopped repairing their insulators or stopped cleaning their insulators. So to me, this is a root cause. I know that staff says we don't know what the root cause is for the insulators, but this is a tried and true issue. And with finding out that we didn't maintain the insulators, could be something that, FTA is interested in, because they clearly told WMATA, directed WMATA to further replace the insulators and maintain the insulators. So this is very serious to me. I don't know what we're going to do with this report. I don't know if FTA is going to get involved with this. I don't really want them to get involved. But I would like to go to the next steps, please, because I think it gets to what you want to do. The next steps. Oh, yeah. So this is great. I mean, conduct additional research on insulator designs and materials and cleaning practices. So this is what the FTA asked WMATA to do. So I think we're on track with this. But I want it to be a direct result of what we didn't do. We didn't clean, and that is essentially the root cause. And this is what we're going to do now. The next step, we're going to look at
Just to be clear, Director, you should be, I would caution us.
Okay.
Michael was very clear, the Deputy GM was very clear, our experts in this field were very clear that the insulator, the cleanliness of the insulators was not the root cause. So I would just caution us to choose your words wisely, because as of right now, that's not the case. So I just got to push back and just ask you to be careful there.
Okay, maybe we get some more data and then we can figure out this is a link. The lack of cleaning relates to a new program, less flashovers, less explosions. I do appreciate that you clean the insulators in the tube, so that's a step forward. And I know Shane said he was going to start cleaning the insulators, even though he knew the report was coming out.
But
So I
you heard,
appreciate that very
Director,
much.
again, I'm going to be clear, you heard from our experts here, the insulators, the cleanliness of the insulators, that alone by itself was not the singular root cause. You've heard that, and you keep pushing, you keep trying to make the statement that it is not that.
So are we deciding right now that it's not true, that the cleaning has nothing to do with the exploding insulators?
Isolated just the cleanliness of the insulators, no.
Okay, I beg to differ. If we go back in time, I'd like to go back in time to see what insulators blew up with BART's history and find out what we did. If there was an insulator issue with BART, I would like to know, to just validate what I'm saying. So I see your point. We don't want to jump to conclusions, but I want to see more maintenance data and historical data that happened to BART. If we had blown insulators and we started cleaning and it resolved the issue, then maybe then we're done.
So I don't know if we'll ever be done, Director. It's continuous improvement. That's what we're all about, So I would just say, Director, I hope you're with me and Michael and the team up here. What we're trying to do is minimize these occurrences, eliminate these occurrences, right? And with the best possible data that we have. That's where we want your help with, right? And we have 100,000 insulators out there, and insulators go out, not just on BART, on other systems. And so we're doing the work right now. So we're moving forward to collect the data, to find out where the risk points are, eliminate those risks with the goal of eliminating these outages in the future, moving forward, all right? We're not going to spend, I'm not going back 10 years and looking at every single insulator that went out. Yeah, I'm not.
I just want to try to correlate the cleaning related to the exploding insulators. That's all. I mean, I'm just trying to rule
I'm
out
moving
that.
forward to make this world-class operation even more world-class, Director Ames.
Right. I'm on the same page with that. So going to the vehicles, we want to look at the vibration study and the fuse assembly. I just like to know, can we get more information of why the shoes are coming off and if that's causing a flashover? I mean, that's just a next
Again, the
step.
shoes, the paddles and the shoes, they're all designed. Leah, we're going to bring you in, and I'm being very, I'm trying to help us move this discussion forward because I want to hear if we've missed anything, if you think that we're short here or need to pay attention more there. But the design, happy to bring you in, Director Ames, and give you a graduate level course with Leo and his team on the design and how the paddles are designed to the shoes, to the cars, and how the power. Happy to do that and walk you through very with great detail, and so that you can fully understand how that works.
Yeah, and I want to appreciate, I do want to say to Bart that we have done a lot of work in the system. We replaced the 34.5 kV cable from Balboa to the West Portal. We replaced a lot of equipment related to grounding, monitoring the currents in the system. Sylvia, you had brought up, you want to show that slide that you brought up that showed that we spent $22 million. I think that was another slide you had on there.
That's not on the slide, but it's the MPRs, if we go to the MPR.
The multifunction relays.
Yes. So we already have a project in place that's funded for about $22 million to replace those system-wide.
And then we also do retrofitting of negative grounding, which is critical.
Right.
For limiting voltage. So I say Bart's really doing a good job. You're seeing an assessment of our system that may not be the root cause of the insulators, but you're basically showing that it works. It's not, I don't see a real threat here based on what the consultant provided, other than we do have some problems with the trains, the paddles, the fuses, the insulators, and there's a power outage with, for some reason, the substation goes out. And I'd like to know exactly how we resolved that particular issue, which was on the 29th.
Director
But that-
Ames,
I'm gonna-
Director Ames, for the record, the things that you just said are not accurate. We have, unless you are making the assertions that the consultants that we've hired are not professionals, are not credentialed, and are willing to risk their professional engineering licenses, that comment that you just made is not accurate.
Which comment was that?
We have problems with our paddles, we have problems with our fuses, we have problems with our insulators. The consultant just told you that those are not root causes for these incidents. So what you're saying, unless you are asserting that the Parsons team, a global firm, is willfully at this dais telling you untruths, your comments are inaccurate.
So maybe I want to be clear about this. I don't think we have enough information on the insulators. I want to know what the maintenance is, what we were doing and not doing. And I just read off to you that WMATA had a safety directive to maintain their insulators. And I want to know what we're going to do. And I think it is a problem. I'm not saying
Director
they
Ames?
don't know what they're doing.
Director
Okay,
Ames?
sure.
We have other directors in the queue, and we've,
Okay, I'll move on. Thank you.
thank you. Vice President Wright, followed by Director Ghosh.
Thank you. I guess I have to start by saying we are not the WMATA board. Sylvia, have we been issued any FTA directives on insulator cleaning?
No.
Okay. Just for the record, Zara, in your expert opinion, is insulator cleaning a problem at BART?
I think there's certainly challenges to cleaning the insulators. Certainly, that's an issue everywhere, though, not just at BART.
And I think the question is, do you think that's a problem at BART? Or do you think that they're...
Do you think it's the root cause of this?
Ultimately, I would say that based on the evidence, it does not appear to have been the root cause. So with the photo that we presented earlier with the coverboard damage that is directly above the insulator, and you even had a comment from Barney Smits, who also did weigh in on that it's coming from above. The insulator flashover is secondary. It's irrelevant to some extent, whether even there's a hypothesis that even if you had a new insulator in that location, if it was subjected to that type of event from above, it would have probably also failed in the same way. So we are well aware of all of the circumstances, and if you look back at that slide, there were a number of other insulators that were in between that were subjected to this similar environmental conditions, and they did not fail. There are also incidents that do not include insulator failures. And even the ones that did have some insulator involvement, those insulators, in some cases, there's a glow, which we describe as corona discharge. They actually didn't fully fail. They did not flash over, which actually speaks to the resilience of some of those insulators in those conditions. So we are fully aware. Of course, there's no such thing as a perfect insulator, but these are special circumstances, and our team has read the WMATA report. We are well aware of that, but these are different circumstances to what WMATA was dealing with.
Thank you. That on that particular question sounds conclusive to me. Thank you, Zara. Thank you, Sylvia. Thank you, Shane. Thank you, Michael. Thank you, Bob. Where I wanted to start my comments is that I think day-to-day BART reliability is great, and our on-time performance is great. Our ridership is up, crime is way down, customer satisfaction is at historic highs. All of that is true. None of that should be lost in this conversation, and none of that excuses these service shutdowns and disruptions. I know our management knows that, and I don't think anyone is here making excuses. I think the detail and rigor of this analysis speaks for itself, and it shows this is a serious problem that we are taking seriously. I do have questions. And Sylvia, I'm sorry I did not ask more of them in our briefing. In all honesty, it took me a while to absorb this. This is a really substantive analysis. I think it does a disservice to the rigor of the work to limit it to a slide deck and a 2-sentence memo. I've talked about this before, but the item before this, just for example, had a 27-page detailed report in the packet that is the real meat of that item, and I'm disappointed we didn't have that here. I know this is a norm for BART, but I think it is a norm that we need to change. Now, onto the slides and questions. For this, I really want to focus on the things that were in our control and decisions that were made by BART, because there's a lot of things that are not in our control. Can we go to slide 12?
So Sylvia, you could change the slide now.
Okay, thank you. I'm still trying to wrap my head around this one a little bit. I understand why the crossponds were removed. I don't understand why they weren't put back. And I don't understand why for nearly 6 years we went without what seems like a pretty important aspect of our system as it was designed. Can you just speak to that a little bit more?
I'll turn it over to Shane Edwards, the AGM of Operations.
Thank you.
Yeah, Director. So first of all, no excuses. But that being said, it was initially done as a result of a safety factor that was recognized during the TBT retrofit project. In order to isolate the track they were working on, you have to make it an island and disconnect it from the other track, which is going to conduct current and make it has to go somewhere. So every night they would go in at 9 p.m. during revenue service between 9 and 9:30 p.m.
I'm sorry, just in the interest of time. I do understand why it happened. Okay. I'm just asking, why were they not put back, and why did it take 6 years for us to kind of talk about this?
Well, Sylvia mentioned the change control document that we've got to come up with and work together on from a project to maintenance standpoint. We're usually the first ones in and the last ones out, and that's something that you can't close out the project or take in this case, close the project out with under budget, on schedule. And we shouldn't just report that out. We should report that all things have been put back in the same configuration that they were prior to the project starting.
But
yes,
Director, just to be clear,
so we need to have a closeout document.
Yeah, Sylvia's got it together, moving forward. But you're absolutely right. They came out with the Transbay 2 project. They should have put back in. There's no two ways. We didn't put them back in, right? And that's on, the people up here. That's on people in the audience here, from the maintenance folks and the operations folks. They should have been put back in, with that project. Or that project should have had operations put them back in. And so they're back in now. She's got the change stuff in. But, I've had this discussion, that same question, on Tuesday. I'm like, well, take them out, fine, for a safety thing. But they should have been put back in with that project. And there's no two ways about that. So we're owning that. And Shane knows that. But he's not going to sugarcoat over that those bonds should have been put back in.
Thank you. I appreciate that. And just to kind of clarify what you said as kind of the action we're taking in response, do we now have just sort of standardized project language or contract language on returning work sites to normal operating order?
Director Wright, we do not have that today, but we will have it within the next, I don't know, a few weeks for that part. And then we're working with safety on what would be the right configuration control or change control process, because that's something that would, so if this type of event happened in the past, who all needs to sign off that they all agree,
Right.
stack hands, and again, a date of when they're going to be put back. So, yes.
Okay, and are we looking at other projects that have happened just to make sure this kind of thing didn't happen elsewhere?
Yes, absolutely.
Okay, thank you. Slide 17, on the MPRs being disabled. Were these considered in a state of good repair when they were disabled, or were they considered past their useful life?
They were considered past their useful life, which is why we have a project to replace them all.
Excellent. So that, to me, speaks to the lack of funding that we've had for capital improvements, capital work. I appreciate that. Slide 20 on rail relay storage. Something you said on this slide has stuck with me, which is that the way we were storing the rail relays was a maintenance practice forever. And that sentiment to me might be one of the root causes here. I don't know how many other longstanding practices that we might have that are not best practices. I'm not the expert. I'm not trying to pretend like I am. But I do think we should be thinking about a broader commitment to review and to reform where it's needed, not limited to the causes that we've looked at through this analysis, but across our maintenance work. Slide 23. I don't need it now, but I would love it if you could follow up with implementation timelines for all of the in-progress improvements. I would also love implementation timelines for the next steps listed on slide 25.
So we brought that up at our prep meeting, Director. We'll pull together an update, on all of those that are in progress, where we are, the timeline, and we'll provide all that information to the entire board.
Thank you. I really appreciate that. And just in general, this has already been talked about, but I think it seems to me like this is more of an interim update than a final report. Am I correct in that judgment?
We're not done with all the investigation, yes.
Thank you. And I think that's fine. I'm glad we didn't wait for a conclusion to have a conversation about this. I do hope that this will come back to the board as a final report when we're ready. I trust that that will happen. Just to summarize, I think we have confirmed. Thank you. And just to summarize, I think we have done a lot of work to understand what has happened. I think we are doing a lot of things to address potential causes and prevent these disruptions from happening again. And we don't have a sure or short answer to what's causing this, because this is lots of different things at different times in different places, and this is a really complex system. And that's frustrating, but it's honest. And what I want to focus on is having clear timeframes for the next steps that we're taking. I think we need a clear commitment to a broader review of longstanding maintenance practices. Just the fact that you mentioned briefly that we haven't had anyone signing off on system changes is alarming to me. I think we need to do a better job making our performance metrics easily accessible to the public so they don't only see or hear about our performance when it's bad. And I think we need to have some conversations on responsibility and accountability on this, because BART is essential infrastructure for the Bay Area, and that means we can't fail. And we have. It's not about being punitive. It's about taking responsibility. And I just want to close by, again, thanking everyone who contributed to this work and the immense amount of work that's gone into it. It's not conclusive. It is critical. It's comprehensive, and it is deeply appreciated. Thank you.
Thank you. Director Goetsch, followed by Director Flores.
Thank you. I think I shared this during our briefing, that this is a lot for someone who's not an engineer to internalize. At the same time, the board is not the only people who are looking at these reports. So I truly appreciate the depth, the detail, the rigor, and the transparency and the vulnerability with which we are sharing this information. I think it's really critical and important to do it in that way. And I think it would be nice if we had a clear root cause, that it wasn't so messy, that we could just have the insulators and start cleaning them. So I think, we have to keep that in mind. The easy answer would be to have a clear root cause. The more difficult answer is it's a fragile system in many ways that a lot of folks work to keep resilient and work on redundancies to keep BART sort of going and moving. And again, to Director Wright's, to VP Wright's point about we are seeing really high satisfaction with BART service right now. That being said, I do have to say that these kind of failures are devastating for our riders. My bus was 10 minutes late today, and just the stress of like waiting, knowing if I'm going to make it to the meeting on time, it really messes with your day, with your job, with your life, especially it messes with our freeways. It really does drive home the point that we're a critical part of moving people around the Bay. So we do have to do better. But the responsibility for that doesn't just lie with BART, it lies with our funding, it lies with like historical underinvestment in the maintenance of our public transit systems, all of that. So I hope that I don't hope, I know the board has been very clear that we want you to look at this, and we want you to look at it in depth, and we want you to figure out everything that we could be doing better to avoid these incidents in the future. So I would like you all to continue on this and report back on these sort of scenarios, and to understand how electricity moves through our system and what we can do to make it better. I think there are benefits to this study, just in figuring out if there are like small things across the system that we could be doing better. It's almost like an audit of how our system works day to day. What are some best practices that we can implement, along with understanding that some of these challenges around how much time do we have to do this work. I think with the storage of the rails, it's because we have a very limited amount of time to do the work, right? So you're trying to like phase it. So the solutions will not be just engineering, it will also be human factors, it'll be processes, and we have to make sure that in the process of doing this, we don't create any new issues, especially when we're so focused, if we are so focused on the insulators, we know that we stop cleaning them to avoid other issues. So it's a little bit of a game to figure out, how to make the system work for us in the best way possible. I did want to ask, in your further analysis, is there any incorporation of the schedule changes that happened just before the first incident? I think August 11th is when some schedule changes happened. I'm curious about that, or if you've looked at it and put it aside as this is not a factor. I didn't hear that being discussed. And then the second thing is, just looking at where the incidents happen, it's very much in that particular area, and that particular area does see, from my understanding, the most amount of train traffic compared to any other part of the system. So I'm also just curious if you had any kind of control sample where that's comparable, where it may not be exactly there, but somewhere else that sees similar amount of train traffic or that can be tested in any way. So I'm just curious if you had, because as a layperson, that's the first thing that comes to me is the schedule change and the heavy usage of that particular section. So in the sort of traction power load flow analysis that you're doing, is that something you all will consider, or there are plans to consider, or has it been put aside?
No, that's a good question. We did look at the schedule change and what the impact, and also one of the things that we asked for and did review is, for instance, on the 829 incident in the afternoon, to look at all the trains and the cars, the number of cars, and where they were between just past West Oakland and just past Civic Center on a map to see where they were and how the configuration. And then we also compared that to exactly the way the system looked a month earlier to see how many cars, to see if there's anything. And there was nothing mind-blowing out of that, but this is where, when we do the modeling, then we'll be able to put all those trains in and the cars in, and whether they're accelerating or decelerating, and see how that negative return works, and see if there's anything that comes out of that. That's one of the values of that.
I appreciate that. I would have loved it to be one of these sort of bullet points that, in that slide, because I think it's so specific to where it happened, that addressing that will be important to us understanding the entire system. So, okay, thank you so much.
Thank you. Director Flores.
Thank you for the presentation. I just want to begin by stating that I think what's been clearly said, but want to reemphasize that our customers and taxpayers deserve transparency, accountability, and quality service. And this presentation is part of that process. I believe that having an outside group investigate these incidents to provide an outside and non-biased perspective is important, just to make sure that we're not missing anything. And while more analysis work needs to be done, it's important that we have that information early, right now, so that we can share that out with the public. And glad that it is not a final report. We are expecting that to come back, so that we can have more concrete information that's taking place. So just with that being said, I do want to thank you all for the next steps and making sure that we get more details on that and sharing that out. But I do have a few follow-up questions. I was curious about the fuses. It was noted that it showed non-standard failure. Do we have suspected causes for non-standard failure, or is this still something that is too early to tell?
We're currently investigating that, and this is why we've recommended further testing.
Okay, thank you. And then just on the paddles, just so I'm understanding correctly, what it sounds like is that the paddles are designed to brake as a safety function. So if that does happen, could be associated with some of these other causes. The paddle braking in itself would not necessarily be the cause of arcing, blown covers, anything like that, right? Is that what I'm hearing?
So we've looked extensively at the paddle loss. We have data on that. There's a lot of analysis done on the vehicle logs, and it certainly has been included in that analysis. It does appear that it's a maybe a number of factors coming together, unusual circumstances, if you like. It certainly has not been ruled out, but it's part of the analysis.
Okay, that is helpful for me to know. I just want to make sure, one of the things that I feel Director Ames is saying, and she can correct me if I'm wrong later, is that potentially the insulators may be the root cause of some of these issues. But what I'm seeing in this presentation and what I'm hearing is that rather than the insulators being the cause of these issues, it is these other, whether environmental, human, all of these other issues could be the potential causing factors for the insulators being blown, or in some cases they're not blown, rather than the insulators being the cause, right? Is that what I'm understanding from you all right now?
That's correct. There appears to be, in some cases, an underlying factor. Perhaps the insulators may be more susceptible to failure given the conditions, but that doesn't necessarily mean that they were the root cause.
Okay. That's, I think, important for me to understand, just because there's 9, 8, 7 separate incidences with different potentially contributing causes. And they might, I did like what Director Ames said about narrowing it down per incident to see, because there might not be that one single cause. So just understand what happened in the separate incidents would be helpful. So that's all I wanted to clarify, just to make sure that I was on the same page with all of you, because it sounded like there was a lot of back and forth. So I just want to make sure I understood what you were all saying correctly.
Director Flores, even though you didn't ask a question directly, there will be a final report that will come in in the format that Director Wright is expecting as well. In that you saw that one incident that we laid out that showed the insulators. We'll do a similar diagram for every single incident so that you guys will have that. But again, once we get to the final report stage, it'll include that for every single incident.
Yeah. That'll be great. And yeah, thank you all for outlining the next steps and moving forward so quickly. I think that's it for me for right now, and look forward to getting more information at a later point. Thank you.
Thank you. President Hernandez, followed by Director Lee.
Thank you. Sylvia, you and I spoke yesterday with regards to what was going to be in discussion today. And the one thing that I see, BART's been a system for over 50 years. And the one item that I kind of brought to mind was the checks and balances, and making sure that each director that's in charge of whether it's, maintenance or the rail system or any other item is to make sure that we are being proactive. I know we cannot, know every incident that's going to happen, but it's our due, diligence to make sure there's communication and going back and making sure that each item is checked off. And when I say that is when a pilot gets into a cockpit, his responsibility is to make sure he checks everything off before that plane moves forward. And if something is not correct, then maintenance comes in, either they fix the problem and move on, or they actually cancel the flight, and so on. And so what I'm seeing from our discussion a little bit is making sure that each director is responsible for checking off that list. And I just want to make sure that it's clear that each director for each department moving forward understands that, whether it's making sure that there's more checkoffs, making sure that our general manager gets the last word. Can you just clarify just how we're going to do that moving forward?
Well, I think it's a combination. What Shane's direction to his staff and his maintenance departments. I think there's also, though, from a higher level, there's a change. We need to put into place a change control board that has safety, has a general manager, has the AGM of operations signing off, potentially the AGM of OID, depending on if it's a construction project versus a maintenance project. So I think, in initial conversations with our chief safety officer, what he talked about is a change control board, basically. So I think what we'd have to do is use maybe our asset risk register to identify criticality of assets, which we already know what that is. And I think we need to put, a set of criteria that says if this changes in this configuration, you're not allowed to make that change without this sign off. And BART has tons of processes that require us to do system access requests or sites. What's the SSW stand for? Thank you. Site-specific work plans that have to get into place months before we do the work. So we can tack it onto that process, right? That it says this person has to sign off before you can move forward. And I think in some of those cases that needs to get escalated up. And again, part of that has to be, what are you going to do at the end? How are you going to put that back in place? And again, like Shane says, maintenance is in there first, maintenance is in there last. So there needs to be something that triggers that sign off either through maintenance or through the contractor that says that work has been completed.
And President Hernandez, and just to add to what she's saying a little bit more directly, this accountability and however you want to frame it, the check off the pilot and, checking that, those folks that you're talking about, those pilots are in this room right here. And that's why Michael brought them in here, right? It's Mike Gibson. It's Derek Calhoun, it's Leo Pica, it's Jeff Lau, it's Miat San. Those are the pilots you're talking about that are responsible for these elements within the system. And that checklist, that checkoff list before, that's their world. And so having them hear that comment from you is very powerful, because that kind of accountability is what we need to get to what Director Ghosh was talking about improving the system, improving the reliability for our riders. So couldn't agree more.
Thank you, and I just bring that forward because in a city, I always remember back to the city is we tend to do that, right? We want to make sure that before we have something that needs to be fixed because it's aging, then we want to bring it forward in enough time so that we can beat that time lapse. So just wanted to make sure that we're all in the same vision of moving forward, and I do appreciate the thorough report.
Thank you. Director Lee.
I have really brief comments here because so many of my colleagues have said so much. I would like to first associate myself with the comments that have thanked staff and our third-party consultants at Parsons for the extensive investigation. I particularly want to associate myself with Director Wright's comments. Look, we've been at this conversation for what, like 2 hours now? That is such a tiny fraction of the near 15,000 hours that went into the investigation, and no one on this board, love you all, my colleagues, no one on this board are subject matter experts, and certainly we are not subject matter experts on the breadth of knowledge needed to unravel the situations that had happened, which is why we bring in third-party consultants, which amongst all of your people, y'all can figure this out. We're not gonna figure this out. We're not gonna just go into our grab bag of brainstorm ideas and be like, have you looked at this? You have. You've done 15,000 hours of looking at stuff, and we're not gonna do that in 2 hours here, and we're not smart enough to do that in 2 hours here, so I'm not gonna pretend like we can. What I think is really, really important is that BART is safe for our riders. And we know that BART is safe for our riders because it's born out of our data. You can see that in our quarterly performance reviews. I looked at our latest one that you presented back in December, and that covers Q1 of our current fiscal year. So that's July, August, and September, which includes a few of the incidents that you investigated. We have 0.14 vehicle incidents per million riders when looking at our passenger safety numbers. Give or take, we have about 1 million rides per week in our system. So you can see how incredibly rare passenger safety incidents on our trains occur. That puts, I would say, BART as one of the safest transit systems in our country, and that is in the data that we report to the FTA regularly and that we present to the public quarterly. BART is a damn safe system. So thank you for those efforts. With all that said, I'm echoing, what Director Wright said. It's the perception of safety, it's the feeling of safety that makes the difference for our riders in trusting us as a government agency and trusting us and believing beyond just the numbers that we truly are the safest system. And I think that this investigation, these man-hours, this deeper look, and ultimately what will become, a final full report, is that level of transparency we need to give credibility to the work that you've all done, that Parsons has done, to ensure that we remain safe, that we are being proactive, we are learning, we are building into our protocols every step of our construction projects, every step of our state of good repair work, that we are doing everything right, we are being proactive, and we are preventing further incidents from occurring that keep our system running. So I'll end my comments there. Thank you so much.
Thank you, Director Lee. Let me ask a few questions or provide a few comments before we wrap up. So first off, thank you. Honesty and transparency are critical in government, and so you're coming to us today and identifying some areas where we have some gaps that we can fix is important. That does build our reputation in the area, that folks know that we do care about ridership. But I will also be clear that when BART has an issue, it isn't just BART passengers that are impacted. It is the entire Bay Area, and traffic throughout the Bay Area is greatly impacted when we aren't able to provide service. So the world is much larger than the ridership that we live in today. So I look at this as a learning opportunity. This is a chance for us as an agency to identify what we see are challenges that we can address and to understand maybe what are some of the challenges we're not yet seeing. So I welcome this. I feel that ultimately this is in the best interest of BART, but also the greater Bay Area. So that said, did we look at other electrified railways and did they experience similar sort of issues throughout the world? Are we unique in this sense, or is this something that other agencies have experienced, and did we gain anything from that?
Yes, we have looked at other systems, and many team members and SMEs and technical specialists actually have direct experience working for those other agencies. Not just myself, but other members of the team have worked for New York City Transit and other agencies. So that data point, those data points are there. I think it's too early to say right now, but based on our understanding and our analysis, these circumstances appear to be quite unique to this system.
Thank you. We've been told BART's unique many times before,
Okay.
so understood. As part of this sort of data analysis, did we bring in Alstom, the folks that take care of our trains for us, the creators of our trains, to give us some sort of SME feedback?
Director, we did not yet, or Chair, sorry about that. We have not brought them in yet. We wanted to do this completely independent as far as that review, but we do plan to bring them in as we move forward.
Yeah, based on some of what I'm hearing today, I think that it's critical that we bring in our train manufacturer to really look at, are there any contributing issues or potential causes? So I think that would be critical for us to do. And kind of speaking to that issue, do we capture any undercarriage video? Because I think we should explore that if we don't.
We don't right now, but it is one of the recommendations from the team. There's different reasons why we haven't done that, but definitely something we can talk to the chief mechanical officer.
All right. To me, it's another data point and another potential piece of the puzzle to help us maybe identify and see some of these challenges. And then lastly, I know you mentioned rail grinding vehicles and not necessarily being, a root cause, but could be a contributing factor. Have we thought about, I know at home, if you're sanding, some of your tools have a vac built into it so that dust is captured as you're grinding. Have we looked at maybe retrofitting vehicles to try to capture some of that rail dust as we're grinding?
So Director, we have 2 rail grinders on the system. They have vacuum systems on them with 2 collector cars, and they collect as much of the spoils and not micro dust, but dust that it can. And then, but the other thing that we're talking about when we're talking about metal dust is the wheel rail interface, which does not get picked up by a grinder every single night, obviously, because the rail's not going to get any newer and the wheels aren't going to get any newer. So we've got that dilemma as well.
Understood. All right. Well, maybe we need a vacuum truck to run around the system. Anyway, with that, I will conclude my feedback and the E&O agenda items, and I will turn it back over to President Hernandez.
Thank you, Director.